graphical method of solution of solving linear programming problem. The step or procedure on how can we solve a linear programming problem on graphical solution. First step is this method consists of the following steps. One is represent the given problem in mathematical form, that is, formulate the mathematical model from the given problem. Formulation is what to translate it to mathematical description, mathematical form. Then this is what number one is telling us. Number two, draw the x1 and x2 axis. The non-negativity restriction x1 is greater than or equal to 0 and x2 is greater than 0 imply that the value of the variable x1 and x2 can lie only in the first quadrant. This eliminates a number of an infeasible alternative that lie in second, third, and the fourth quadrant. If you have a graph like this is a principle. If you have a graph like this, remember in our graph, our x is our what? X-axis. Then our y is what? Y-axis. Our y is the vertical, our x is the what? Horizontal. If you have y, if you have x, this part, this region, this is origin. Remember, we have this is origin. From here is negative. From here is what? S is positive here, S is what? Negative here. That is, we have negative here, we have negative here as well. Positive here, negative here as well. Why? So our y, because of the board, that is why I have to manage it. Our y is what? Positive here, and our x is what? Positive here. Remember, we have this is a what? This is just a line on plotting on the graph. We have a four quadrant, that is four side. This is first, this is second, this is third, this is fourth. So that's why we call it quadrant. Quadrant means four side. Remember, our y is what? The two that does what? Imply that the value of the variable x1 and x2 can lie only in the first quadrant. It means when we are plotting a graphical method of linear programming problem, we only plot on first quadrant only, because our first quadrant and our x and y axis on the first quadrant, they are positive. This place is positive, this axis is positive, this axis is also positive. It means this is positive, this is positive. We are going to have our first quadrant as well, positive. We go to the second quadrant. Under second quadrant, what is there? Our y is what? Vertical. Our y vertical is positive, our x is what? Negative. Remember, our horizontal come first, then our vertical, that is our x, y, point xy. So it means here is what? Negative, positive. It means our x here is negative, our y is positive. So you check on third quadrant. Our third quadrant is what? This is what? Y-axis, which is negative, and x-axis is what? Negative. It means our x is negative, our y is what? Negative. We go to the last quadrant, which is the fourth quadrant. Here, y-axis is what? Negative, x-axis is positive. So our x is like our x, y. It means our x is what? Positive. Our y is what? Negative. It means all second quadrant, third and fourth quadrant, they are having negative. So our first quadrant is what? All the x-axis and y-axis is always positive. It means since because our x1 is greater than or equal to 0, that is not a negative. It means we are going to plot our graph on first quadrant. So it means that our graph will be like this. When plotting a graphical solution, our graph will be in terms of like this. Our graph will be in form of this. That is this is what? Our x-axis, that is our horizontal. Our y-axis is what? Vertical, which is what? Positive. Since our x1, so our x1 is our x, our y is what? Our x2. That is our x1. We are plotting this against this. Positive. This because it lies on first quadrant. So this is how our graph will be in form of like this. So that is the meaning of question 2. So step 3, plot each of the constraints on the graph. We'll be given a constraint. Linear programming will have a constraint, a set of the subject of linear inequalities or equalities. You have to indicate the constraint, how we mark the constraint on the graph, then identify the feasible region. When we talk about the feasible region is a shaded part. It means while plotting on graphical method to plot linear programming problem on graph, it means we'll be giving less than or equal to as a constraint, that's inequality sign, as well as what greater than or equal to as inequality sign. That is, we're going to have less than or equal to, greater than or equal to on the constraint. It means whenever we indicate our less than or equal to we plot, we are going to shade it. It means whenever we have greater than or equal to, we are going to shade the area part. If it is less than or equal to, we shade it down. If it is greater than or equal to, we are going to shade it what? We are going to shade it up. So the shaded part is called a visible region. So that's why you have to identify the visible region. If it is greater than or equal to, you will shade the region up. If it is less than or equal to, we are going to shade the region down. So that indicates that we have identified the visible region on the graph. These are the steps on how to solve graphical method of solution of linear programming problem. You can make a screenshot of this